Well, thank you for having me. I actually presented a research highlight a couple years ago on this same study, so it's great to be able to come back and share some of our more recent findings after completing a long-term follow-up of this cohort. So just to give you a little bit of background to kind of set the scene. So we know that obesity that develops in childhood or adolescence often persists into adulthood. And it's a strong predictor of increased morbidity and mortality later in life. So intervening early is really important to try and kind of break this trajectory. And one area of interest, particularly in recent years, has been the role of the gut microbiome, particularly given its involvement in metabolism, appetite regulation, and energy harvest. So we know that individuals with obesity and metabolic disorders have distinct gut microbiome compositions. And at least in mice, we know that weight and metabolic phenotypes can be transmitted through fecal microbiota transplantation, or more affectionately known as FMT. But what about in humans? So can we transplant healthy donor stools to people with obesity? And could this be a therapy to help them lose weight? And so the GutBugs trial was set up to try and address this very question. This was a double-blinded, randomised placebo-controlled trial. We recruited 87 adolescents with obesity. To start off with, we gave them a laxative solution to try and cleanse out their bowels. And then the following day, we invited them to clinic to receive either FMT or placebo capsules. And for those in the FMT group, we used a multi-donor approach where each FMT recipient received an equal dose of microbes from 4 healthy, lean sex-matched donors. Participants also underwent a range of clinical assessments, and we initially followed them for up to 6 months. Now, unlike the kind of impressive experiments we'd seen in mice, unfortunately, in humans over this time frame, FMT did not appear to have any beneficial effects on body weight, nor did it influence many of the other secondary outcomes that we were interested in. However, we did see some improvements in terms of fat distribution and in those with metabolic syndrome. We also found that it was highly effective in shifting recipients' gut microbiomes, both structurally and functionally. And so then this kind of made us wonder, what if 6 months isn't really a long enough amount of time to wait to see the effects of FMT on body phenotypes? Perhaps in humans, maybe these effects take a longer amount of time to manifest. So a couple of years later, we invited everyone back for a long-term follow-up assessment. So at this stage, it had been just over 4 years since they had received treatment. And while some of our participants had kind of moved on, we were able to bring back 64% of our original FMT group and 62% of our original placebo group. And if we focus first on our placebo group, looking at some anthropometry and body composition results. So the small cluster of dots here on the left are the average values from the original trial. And then on the other side here, we have the average group value 4 years on. So looking at the placebo group, we can see that kind of as we expected, our placebo group have continued to gain weight. Their waistlines have gotten larger and their body fat percentage has not really shifted at all. However, what about our placebo group? Our FMT group? Well, to our surprise, their trajectories looked quite a bit different. So firstly, it looked like their weights had somewhat stabilized. And although it wasn't quite significant, they were around 12 kgs lighter on average than our placebos. It looks like their waistlines had gone up slightly, but they were still around 10 centimeters less than our placebo group. And they also had about 5% less body fat, with their body fat percentage having actually reduced since we had last seen them. It's obviously not all about appearances. What we're really interested in finding out is if we've been able to shift their morbidity risk. And so to assess this, we looked at a score known as the Metabolic Syndrome Severity Score. It's kind of like a population-based risk score, which takes into account not just abdominal obesity, but also fasting glucose, lipids, and blood pressure. We were delighted to see that in our FMT group in blue here, their severity scores had declined over time. While in our placebo group in yellow, we can see that these scores had actually gone up, indicating a further deterioration of their metabolic health. We next looked to see if any of these effects could have been driven by a change in lifestyle factors. And we're particularly curious to look into this because we had unblinded our participants at the end of the original study. And so this may have changed their subsequent behaviors. So we asked everyone to complete a variety of diet and physical activity questionnaires, and we conducted a full medical history to get a good understanding of their lifestyle and any supplements or medications that they might have started taking. And I don't have time to go through all the data here, but essentially what we found was that there was no differences between the two groups in terms of their diet quality or their physical activity levels. And a secondary analysis we ran ruled out the influence of any medications. So this was quite exciting. So it suggested to us that perhaps these phenotypic differences that we were seeing were in fact being driven by the gut microbiome. So to investigate this, we collected stool samples, we performed shotgun metagenomic sequencing, and we used the BioBakery3 suite of tools to profile their gut microbiomes. And so first looking at their species richness, or rather their change in richness from baseline, we can see that the placebo group's microbiomes have become less diverse over time, while our FMT group have more or less retained their species richness. We then looked to see if their microbiomes had drifted back towards their original composition, and what we found was that the FMT group still had a higher dissimilarity to their baseline sample compared to the placebo group. This was both in terms of their species and also their pathway composition. We also did a bunch of differential abundance testing, which again confirmed that we saw a higher proportion of differentially abundant species and pathways in our FMT group compared to their baseline sample, which were not seen in our placebo group. Their gut microbiomes remained largely unchanged. We then looked at the genetic similarity between recipient and donor strains to find out if any of the donor strains were still present in the recipient gut 4 years on. So from our first study, we knew that we had quite a variable level of donor strain engraftment in the original study, but again, we were quite surprised to see that even after 4 years, we still see a similar proportion of donor strains making up the recipient gut microbiome. And this was true of both bacterial and also viral strains that we looked at. Because we had used a multi-donor design, we also had this unique opportunity to kind of monitor which of the 4 contributing donors these strains belong to. And what we discovered was that while we could see strains from all 4 of the donors, in the female pool, we had 1 donor as well as in the male pool that tended to dominate engraftment, meaning that a higher proportion of their strains were engrafting and sticking around within the recipient gut. So what was so special about these 2 donors? Well, we don't know exactly for sure, but both of them were at the higher end in terms of their species richness and Shannon diversity when compared to the other donors in their pool. And so this suggests to us that microbiome diversity is an important factor to consider when selecting good donors for FMT. Again, I don't have too much time to go into this, but I just wanted to say that we did explore associations between the microbiome and the clinical improvements that we saw, and we identified a number of taxa of interest. However, whether these species are playing kind of a direct role in driving these effects or are just simply markers of an improved metabolic state remain to be determined. So to summarize now, what we found was that a single FMT treatment can induce long-term shifts in the gut microbiome composition via the stable engraftment of donor strains. And we think that these changes may contribute to improved metabolic regulation, potentially slowing the metabolic deterioration that's often seen from adolescence to adulthood and obesity. Now, these effects appeared to be largely independent of lifestyle factors such as diet or physical activity, supporting the notion that the microbes themselves may be playing a role. And while we did identify several microbial taxa of interest, further research is needed to kind of better understand the underlying mechanisms. And in order to sort of support this work, what we really need to see are some larger RCTs, firstly to help kind of validate these findings, but also to provide some kind of larger power to help tease out which microbes or groups of microbes might be responsible, with the ultimate goal being, shifting away from kind of using crude fecal material to something slightly cleaner and more standardized. And just to close quickly with an acknowledgement, obviously multi-layer trials like this require hard work and expertise of many different people to help bring it all together. And so those are the faces that you can see here. Thank you.